In Chapter 7, Section 4, we're going to apply all those properties of similar triangles and use proportions to solve for various things. So by the end of this lesson, you should be able to use the properties of similar triangles to find segment lengths, and also apply proportionality and triangle angle bisector theorems. So here's our first theorem. It says if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So this line here, EF, is parallel to BC. That means that A over E and E over B has to be proportional to AF and FC. So let's do an example. We need to find US, this distance right here. So because these two lines are parallel, we know that these lengths are proportional to these ones. So we can set up a little proportion. 10 over 4 has to be proportional to 14 over x, the thing that we don't know. And if we do 10 times x, we get 10x, and 14 times 4 gives us 56. And if we divide both sides by 10, we end up with x has to equal 5.6. So this distance up here has to be 5.6. Next theorem. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. Hopefully this sounds familiar because it's just the converse of the theorem that we just solved. So it's the backwards version. It says that if these two are parallel to these two, then we know that these lines have to be parallel to each other. So the types of problems you're going to see for this are ones like this, where you have to verify that two lines are parallel, that DE is parallel to BC. So what we're looking for is we're checking that these two sides are proportional to these two sides, 15 divided by 12. So there's several ways to check this. You could type this in your calculator, 10 divided by 8 and 15 divided by 12, and see if you get the same thing out. Or you could do cross products again, and you should get the same thing. So is 10 times 12 the same thing as 15 times 8? And you do end up with the fact that they are both 120. So because of that, you know that these are proportional. And because they're proportional, the converse of the triangle proportionality theorem says that these two lines have to be parallel to each other. So DE is parallel to BC. Next theorem. This one's a little different. It doesn't have an actual triangle in it, but if we were to continue these lines up forever and ever, it would eventually form a nice little triangle here. So that's why they stick it in. So if three or more parallel lines intersect two transversals, then they divide the transversals proportionally. So it's kind of like the triangle thing, because again, you'd have a triangle there. But if we think about it without the shapes and just take a look at the lines. So in this one, we have three parallel lines cut by two transversals. We know that A over C divided by C over E has to be proportional to this side. So here's a problem. All of these trees are parallel to each other, and we need to use the diagram to find LM, this distance here, and MN, this distance here. So we can use what we know up here and the information that they give us. We know that AB over BC has to be proportional to KL over LM. And we can fill in the blanks with almost everything besides the LM. So 2.4 over 2.6 has to equal 1.4 over x. And then we can do some cross products. 2.4x, and then 2.6 times 1.4 is 3.64. And if we divide both sides by 2.4, we end up with a number that we got to round to the nearest tenth, so 5.1, or 1.5. So that tells us that this down here is 1.5 centimeters. So now we can do the same kind of thing to find the last one, the MN. So again, we know the AB and BC and that has to be proportional to CD over MN. So set up the same 2.4 divided by 2.6. This time has to be proportional to 2.2 over the x. So again, we get 2.4x on this side, and 2.2 times 2.6 gives you 5.72. We divide both sides by 2.4. We got to round again, so we get 2.4. Next theorem. This one's a little different because it talks about angles rather than the sides. But it starts off and it says, an angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So if you have an angle bisector that cuts the angles in half, it doesn't have to cut the side of a triangle in half, but we know that these two, BD over DC, have to be proportional to AB over AC. So for this example, we need to find PS and SR. We can solve for X. So we know that because of this down here, that this is an angle bisector, that PS over SR has to be proportional to PQ over QR. The sides, and then the ones that were cut in half. So PS is the x minus 2. SR is x plus 5. That has to equal PQ, which is 32, over QR, which is 40. And be careful when you do your cross products here, because you have a binomial, you have to distribute. So you end up with 40x minus 80 on this side equals 32x plus 160. And then some quick math, we'll subtract 32 and we'll add 80. And then divide both sides by x, by 8, and we get the x equals 30. So then to find the two things that we have to find, we got to plug stuff back in. So PS is x minus 2, so that means it would be 28. And SR is x plus 5, so that means it would be 35. And then remember, you can check these by plugging them in. Is 32 over 40 the same thing as 28 over 35? And it ends up being exactly the same ratio. So you should be able to use the properties of similar triangles to find segment lengths, and then apply the proportionality and triangle angle bisector theorems that we just did to solve those problems. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.